We need to show that derivative of y with respect to x is given by the following expression when we have a function in its implicit form. So let's begin. We begin by considering our implicit function, which is given by square root of 1 minus x squared plus square root of 1 minus y squared equals to a times x minus y. Let's label this as number 1. Now what we can do, instead of taking the derivative with respect to x right away, we will make a trigonometric transformation here. So what we'll do, we'll consider x to be equals to sine theta and y to be equals to sine phi. Now this has been done because if we take the derivative on both sides with respect to x straight away, we have radicals involved there and it will make it extremely lengthy. What we'll do, we'll try to simplify this problem. Now what we have, we'll substitute this value into equation number 1 to get 1 minus sine squared theta plus square root of 1 minus y squared. So that means 1 minus sine squared phi. So this value will be equals to a times x minus y. So that means we have sine theta minus sine phi. Right. Now we know that sine squared a plus cosine squared a, this value is always equals to 1. In our case, we have theta. So when we have sine squared theta plus cosine squared theta equals to 1, then we can have square root of 1 minus sine squared theta replaced with cosine of theta. Similarly, square root of 1 minus sine squared phi will be cosine phi. So this will be equals to a times sine theta minus sine phi. Now what we'll do, we'll have to combine sine theta plus sine phi. For that, we'll have to use the fact that whenever we have cosine of A added to cosine of B, that's given by 2 times cosine of A plus B divided by 2 multiplied to cosine of A minus B divided by 2. And if we have sine A minus sine B, then this will be equals to 2 times cosine of A plus B divided by 2 times sine of A minus B divided by 2. Now what we'll do, we will use this formula cosine of A plus B to add cosine theta plus cosine phi. Now that means, let's label this as number 2. Now 2 will become 2 times cosine of theta plus phi divided by 2 times cosine of theta minus phi divided by 2, which will be equals to 2a times cosine of theta minus phi divided by 2 times sine of, this is theta plus phi, sine of theta minus phi divided by 2. So immediately we can see we have 2 times cosine of theta plus phi over 2 cancelling out from both sides, and that leaves us with cosine of theta minus phi divided by 2 equals to a times sine of theta minus phi divided by 2. Right. Now what we can do, we can rewrite this expression as sine of theta minus phi divided by 2, the whole divided by cosine of theta minus phi over 2 equals to 1 over a. Now the ratio sine over theta, sine over cosine, that's our tangent function. So we have tangent of theta minus phi divided by 2 equals to 1 over a. Now I'll take the inverse tangent on both sides to get theta minus phi over 2 equals to tangent inverse of 1 over a. Now cross multiplying 2 gets us theta minus phi equals to 2 times tangent inverse of 1 over a. Now we started out by considering x to be equals to sine theta. So this means that theta must be equals to sine inverse of x. And we considered y to be equals to sine phi, which would simply mean that phi must be equals to sine inverse of y. Now we will substitute the value of theta and phi with its corresponding inverse trig function. So that means we now have sine inverse of x minus sine inverse of y. That this will be equals to 2 times the inverse tangent of 1 over a. Now what we have done, this is number 3. We started out with the implicit function given by equation number 1. So after making the two substitution, x with sine theta and y with sine phi, we have obtained an inverse trig equation. Now what we'll do, we'll take the derivative on both sides with respect to x. So we have derivative with respect to x of the inverse sine of x minus derivative with respect to x of inverse sine of y, which will be equals to 2 times derivative with respect to x of tangent inverse of 1 over a. And we know that when we take the derivative with respect to u of sine inverse of u, that this is given by 1 divided by square root of 1 minus u squared. That means we now have 1 divided by square root of 1 minus x squared minus derivative of the inverse sine of y will be 1 divided by square root of 1 minus y squared. Now since here we have y instead of x, so we will need to use the chain rule. We'll multiply the value with dy over dx. This will be equals to 0 because tangent inverse of 1 over a is a constant, because a is a constant here. When we finally rearrange the terms, we should get dy over dx equals to square root of 1 minus y squared divided by square root of 1 minus x squared. So this was what we were asked to prove. Hence,